Here's an example of a function that is an image of the cosine function. And this one has both a scale change as well as a phase shift. I can tell it has a scale change because there are some values that are being multiplied by things within the function, and I can tell there's a phase shift because of the addition. So we know that the first thing that we need to do, and it would be a phase shift if it had addition or subtraction, but the first thing we need to do is to identify our scale change and translation rule. Now, as we did in class the other evening, we've got to first do that preliminary step. Whenever there is a number multiplied by the x, we have to factor that number out of both of these things inside. So we're going to divide by 6 and just put the 6 out in front. Okay? So when I do that, my equation will be y is equal to 2 cosine. I'm going to put the 6 out front. And when I divide 6x by 6, I'll get x. And when I divide pi by 6, I'll get pi over 6. So now I see inside the parentheses I have a 1 in front of the x, which is exactly what I want. Now I can identify my rule. So for the scale change, I notice that in the equation, x is multiplied by 6. So that means that in the rule, x will be multiplied by the reciprocal of 6. And I know, once again, that my b value gives me what the y gets multiplied by. So the y's will be multiplied by 2 in this case. There's my scale change rule. The translation, or phase shift, I can see that in the equation I've added pi over 6 to x. So in the rule, I need to do the opposite, subtract pi over 6 from x. There is nothing that has been added or subtracted to the y, to or from the y, so the y will not change. So I've completed my preliminary step. I had to factor out the 6, and my first step, I had to identify my rules. Second is I need to determine the horizontal and vertical scale. So the horizontal scale in our parent function is pi over 2. We multiply that by a to determine the horizontal scale here. A is 1/6, it's the number multiplied by x. So pi over 2 times 1 over 6 would be pi times 1 over 2 times 6. My scale on the horizontal axis is going to be pi over 12. This is 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, and so on. Those could be reduced. My vertical scale, we know, is just my b value. And so my b value is 2. I'm just going to spread this out again a little bit, and I'm going to go down 2 lines and up 2 lines. All right. The next thing I want to do is determine my bump. Okay, it's not necessarily the y-intercept, but it is the first bump. So the first bump here, I know that the bump on the cosine function is 0, 1, because at 0 radians, cosine is equal to 1. I need to apply the scale change rule to that. So I need to take the x, multiply it by a 1/6, and then apply the phase shift rule to that. And that is subtract pi over 6. I need to do the same thing with my y. I need to take y. Whoops, I don't want parentheses there, sorry. I need to take y, 1, multiply by 2, like in the scale change rule, and then there's nothing to add because there was no vertical shift. So 0 times a 1/6 is 0, but minus a 6, pi over 6, gives me negative pi over 6. 1 times 2 is 2. So I'm going to have a bump just to the left of the y-axis at negative pi over 6. Now, negative pi over 6, a little bit of fraction review. My scale is in twelfths, so I could put this in twelfths by multiplying the top and the bottom by 2, and I'll get negative 2 pi over 12. So my first tick mark to the left of the y-axis is negative 1 pi over 12, so my next tick mark right here is negative 2 pi over 12. And at that point I need to go up to 2. Okay? Now every tick mark, I know usually they go 1, 0, negative 1, 0, 1, 0, negative 1, 0, but here it's going to go 2, 0, negative 2, 0, 2, 0, negative 2, 0. So every tick mark, 2, then 0, then negative 2, then 0, then 2, then 0, and so on. To the left of this bump, I'm going to have every tick mark, 2, then 0, then negative 2, then 0, then 2, then 0. So I can see my transformation of this cosine function looks something like this. My amplitude is clearly 2 from top to bottom, half the distance. My range goes from 2 to negative 2. My domain, of course, is still all reals. My period from bump to bump, well, I could look at this bump and count every tick mark. There are 4 tick marks, each of which is pi over 12. So 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12 reduces to 1 pi over 3. The other way to determine that period, or wavelength, some textbooks call it, is to take 2 pi and multiply it by a. Well, if I take 2 pi and I multiply it by a, in this case 1/6, I get 2 pi over 6, which reduces to 1 pi over 3. Let me know if you have any further questions. I can make other videos in addition to these.